So dear students, we were solving the problem. This container is given to us, liquid is filled into it, this wooden cylindrical block is there. It is first of all placed here so that this block is floating and the liquid level rises. Situation becomes something like this. And then this block is depressed into the liquid in such a way that topmost surface of block remains above the liquid surface. That means this block is depressed, but it is not taken into the liquid completely. It is not completely inside liquid, right? And then the block is released. So it is found that the block performs simple harmonic motion. Dear students, this situation is different from the situation that we generally solve in classroom. And this situation becomes very important for JEE Advanced. IIT professors will definitely ask something around it in few years to come. See, generally what do? We take very large container and large amount of liquid to make it sure that when simple harmonic motion of the block is there, the level of liquid remains same. Generally we do that, but here it is not the case. Here, when this block is performing simple harmonic motion, the level of liquid will also be changing, right? So let us see what can we do in this case. First of all, dear students, because you must have attempted the problem, first of all, the final result. Dear students, the final result is omega, the angular frequency, is equal to whole under root 4 by 3 rho g upon sigma L naught. It is very, very important for JEE Advanced. And see, we are not getting the result, this one, under root rho g upon sigma L naught, that we usually get. Why we are not getting this usual result? Because the level of liquid is not fixed here. The level of liquid is changing when simple harmonic motion is happening. Dear students, from the knowledge of simple harmonic motion, we know that if a particle is moving along y-axis and the particle follows this equation, A equal to negative omega square y, it represents simple harmonic motion having angular frequency omega and mean position y equal to y naught. But if we get this equation, A equal to the acceleration of the particle, A equal to minus omega square y minus y naught, it is once again simple harmonic motion having angular frequency omega, but mean position y equal to y naught, right? So dear students, let's come to the case given. This is the initial situation. Liquid is filled. Let us take this height as h0. 5L0 has been taken here as h0. And for dealing this simple harmonic motion, we've taken origin here and downward direction is y-axis. This origin is a fixed point. So this origin is in the initial level of liquid when there was nothing inside the container other than the liquid. Alright, dear students, the block is placed and the block is performing simple harmonic motion. This figure represents any moment when the block is performing its simple harmonic motion. So see it carefully. This level of liquid is ... here. But at this moment the liquid has reached this level. This dark line is the liquid at this moment. So see, R2 is 2R0 and R1, this radius is R0. So this length is Y and this is X and length of the block is L0, right? So first of all, the logic one is what? Volume of liquid is fixed. This liquid and this total liquid is the same. So initial volume of liquid pi R2 square H0, this liquid, is equal to what? We can take this liquid, right? So we can take pi R2 square times H0 plus X. H0 plus X is what? This H0 plus this X. Minus pi r1 square x plus y. What is this pi r1? This is, see carefully, 1, 1, 2, 3, 4, 1, 2, 3, 4, 1. This volume is this, right? So this volume equals this volume. Simplifying this equation, we are getting x equal to r1 square y upon r2 square minus r1 square. Because we are going to get some equation for SHM, so we must be knowing relation between x and y. Dear students, we can write weight of the block, W. We can write the upthrust, instantaneous upthrust acting on it. So weight is what? mg. Volume of the block, pi r1 square L naught volume times density of the block, sigma times g. We can write bind force, upthrust. Volume of the fluid displaced, pi r1 square x plus y. Volume of the fluid displaced times rho g. So can we write B minus W, difference of the two forces? It is this minus this we are getting. And let us write this, negative of this force is equal to mass multiplied by acceleration. So this is the equation. This negative sign is the usual sign in the equations of simple harmonic motion, and we very well know this negative sign represents what? The restoring nature of force, right? So this A becomes what? Simplifying this equation, A becomes negative this term multiplied by G. Now here we are getting x and y, and we already know the value of x. So let us place this value of x here, so everything becomes in y. So placing the value of x here and simplifying this equation, we get A equals negative this value times inside bracket y minus this value. So this equation is nothing but A equal to negative omega square y minus y naught. It should be noted that this equation has been written in inertial frame of reference. Look, liquid surface is moving, the block is moving, everything is moving, that is okay. We have taken our origin here, this is the fixed point, and with respect to this fixed point, we are watching this particle. So this particle is performing SHM, that means this complete block is performing SHM, whose equation is given by this. So angular frequency is what? Under root of this term, under root of this term, R2 and R1. What is R2? Twice of R0. What is R1? R0. Placing the value of R2 and R1, we are getting whole under root 4 by 3 rho g upon sigma L0. Dear students, in objective type section, if they give choices, one choice is this, the other choice is under root rho g upon sigma L0, then accurate value would be under root 4 by 3 rho g upon sigma L0. Do take care of it, right? Dear students, you must have got your All India rank. Keep working hard to improve your All India rank. Remember, JEE Advanced is not difficult. It is simple, right? Revise it. The next revision problem will come in next 24 hours. Follow the complete video chain to get a grip over what exactly IIT professors want. Happy learning, dear students, and remember, सारे जहां से अच्छा हिंदुस्तान हमारा.